Hi everyone. So today we will discuss the October 2021 M2 paper. Let's start with the first question. A particle of mass m is held at rest at a point A on a rough plane. The plane is inclined at an angle alpha to the horizontal where tan alpha equals 5/12. The coefficient of friction between the particle and plane is 1/5. Mark down the tan alpha value is 5/12. I think it's better that we write down our cos alpha and tan alpha as well, right? So if your tan alpha value is 5/12, tan alpha is opposite over adjacent, which gives by Pythagoras theorem. I get the hypotenuse as 13, right? So we'll write down the sin alpha, cos alpha as well. Sin alpha is opposite over hypotenuse. Cos alpha is adjacent over hypotenuse. And then the mu value is given here. The mu value is 1/5. And this is a rough plane. Okay, so this is the points A and B lie on a line of greater slope of the plane with B above A and AB distance. The distance between A and B is D. Okay. Then they say you show that the work done against friction as the particle moves from A to B. Show that the work done against friction as the particle moves from A to B is 12/65 mgd. Okay. So it's just 3 marks, right? So how do we find the work done against friction? Work done. Normally, what's the principle? What's the formula we use for work done? Work done is equal to what? Force into the distance you move along the direction that you are moving. So work done is force into distance. Force multiplied by the distance that you are moving along the direction of the force. Okay, not just any distance, but the distance you move along the direction of the force that you are along. I mean the direction that the friction is working. So the force, obviously the force here means the friction force. How do we get the friction force here? So they say your particle is moving from A to B, right? The particle is pushed up the line of greater slope from A to B. So when your particle moves from A to B, what are the forces that is acting on the particle A? So you have definitely the friction, right? The friction is acting downwards. Okay, I think we don't need to apply the direction at this point. So let's find the friction. Friction is equal to what? Friction equals to mu r. So friction equals to mu r because we have the maximum friction. We have the mu r maximum friction since our object is moving. So mu is given to you. Mu is 1/5. What about the normal reaction? You all know that the normal reaction here. So this is the mg. The weight is mg. So normal reaction is equal to what? The component of mg, right? Which is mg cos alpha because this is the angle alpha. Mg cos alpha. This side we have mg sin alpha. So anyway, R will be equal to mg cos alpha. Mg cos alpha. So I get here 1/5 into mg cos alpha we found as 12/13. Do you agree? So I get 12/5 times 13 gives me how much? 65, right? 5 times 10 is 65 mg. Do you agree? So this is my friction force. So now how do I find the work done? So work done against friction is we multiply the friction force along the direction, along with the direction that you move with the friction force. So what's the distance that we are moving? Friction is 12/65 mg, and what's the distance that we are moving? We are moving from point A to B. The distance that we are moving here is D. Do you agree with me? Force into distance. So therefore 12/65 mgd, which is our show that. So we get our show that. Part B, the particle is then held at rest at B and released. Okay, so they keep the particle at point B and they are releasing it. They are asking you use the work energy principle to find in terms of G and D the speed of the particle at the instant it reaches A. So you are supposed to find the speed of the particle when it reaches A by using what? By using the work energy principle. So how does the work energy principle work when you move from A to B? Let me write over here. So work energy principle, how does it work? So the work done, basically here the work done against friction, isn't it? The work done against friction is equal to what? Is equal to the change in energy, isn't it? Work done against friction is equal to change in energy. So work done against friction, the change in energy. Now we are moving, the object comes from B down to A, and I think they say they are releasing it from rest, right? The particle is held at rest, and then they're releasing this from rest. The particle comes down to point A, and obviously at point A it will have a certain velocity. They're asking you to find the speed of the particle at the instant it reaches A. Okay, so then what kind of, I mean, you all know if you have friction, when you consider the energies, now I'm considering the energy at B and the energy at A. So which energy is higher? Now, since you have an external force acting on the object while it's moving, so what do you think will happen? The energy at B, and when you consider the energy at B and energy at A, energy at B is definitely larger, right? The initial energy. So change in energy is the initial energy, which is higher. The initial energy we subtract from the final energy, because the final will definitely be lower because there is an external force, friction acting on this. Okay, so let's compare what's happening here. So I'll take it from A to B. I'll consider this point A as my lowest level, or the potential energy 0 level. Okay, so this angle alpha, I'll take it over here through corresponding angles. Do you see? Through corresponding angle alpha comes here. So what happens when the particle travels from B to A? At point B, the initial speed is 0. So at point B, what do we have? If I consider this point A, I'd like to consider the place where I'm ending as my potential energy 0 level. So which means at point B, what energy do we have initially? What energy do we have initially at point B? We have gravitational potential energy. So we have potential energy. So we have potential energy which is losing or gain. When you come down, when you come down, you can see you have a potential energy loss. You can use these words. Basically, at the beginning, you have potential energy. That's all, right? There's no kinetic energy. Minus, what about the energy at the end when you reach point A? Yeah, if you reach potential energy 0 level, you don't have any potential energy when you come to point A. You're at the 0 level. So, but you have gained a certain velocity. You have gained a certain velocity when you come to this point, right? Erase these other things. Okay, so then when you come to point A, you will come to point A by reaching a certain velocity. So that's going to be a kinetic energy. There's no PE. So you have a kinetic energy, what? Gain or a loss? It's a kinetic energy gain. Because when you come to this point, it's a KE gain. Do you understand this? And the work done. So the work done against friction. So here it's work done against friction is equal to the potential energy loss minus kinetic energy gain. So work done against friction. Now earlier we were calculating the work done against friction when we travel from A to B. Now do you think the value for the work done against friction, will it change when you come from B to A? What do you think? Work done against friction is friction force multiplied by the distance. So will there be any change in the friction force? Change in the sense when you come from B to A, the direction will change. But however, will the magnitude of the friction force change? Mu r? That will not change, right? Regardless whether you're coming down, mu r is exactly the same because mu is constant and normal reaction is still mg cos alpha. So mu r is the same and the distance that you're traveling is still B to A, the distance B. So basically your work done against friction will be the same. Do you agree with me? So let's input the value. It's 12 over 65. It's 12 over 65 mgd. Potential energy is mgh, right? mg, what is the height? What height are we using when it comes to potential energy? At the point B, we need to consider what height? We have to consider the perpendicular height, right? Not just the slant height, but the perpendicular height. What is the perpendicular height here? D cos alpha or D sin alpha? D sin alpha. Are you with me? mg into D sin alpha. Minus the kinetic energy gain is half mv square. Are you with me? It's half mv square. Okay, then let's get the answer. Now they ask us to use the work energy principle to find in terms of G and D. So always read the question. They say here to find your answer in terms of G and in terms of D. Okay, then you're supposed to find your V in terms of G and D. What cancels out here? I think you can see the m term will cancel out. Do you agree with me? And we can input the sine alpha value and multiply the whole equation with 2 because I want to make v square the subject. There's a half here. So my target is to make v square the subject. So I'll multiply the whole equation with 2. So what do we get here? 12 over 65. When you multiply with 2, I get 24 over 65. mgd equals here 2gd sine alpha minus v square. Do you agree with me? Yeah, we cut them. Did I write them again? Yeah, sorry. This m is not there. Okay, 24 over 65 GD equal to GD sine alpha minus V square. Shall we input the values here? I'll take the negative V square here and I'll take this to the other side. So I get here V square equals 2GD sine alpha minus 24 over 65 GD. Do you agree? Sine alpha value we found. Who is sine alpha? Sine alpha is 5 over 13. Do you see? So simplify this. This will be V square equals 10 over 13 GD minus 24 over 65 GD. Simplify, what do we get here? 10 over 13 minus 24 over 65. And that gives me 2 over 5. Is this okay? So V square equals 2 over 5 GD in the numerator. GD is in the numerator. So then V equals to square root of 2 over 5 GD. Is this clear? So this is it. This is the speed of the particle at the instant it reaches there in terms of G and D. Okay. Question number 2. A vehicle of mass 450 kg is moving on a straight road that is inclined at an angle theta to the horizontal where sine theta is 1 over 15. Okay. At the instant when the vehicle is moving down the road. Okay. So I think we'll draw the diagram. So we have the vehicle. The vehicle is moving down the road. I'm just drawing something here. Vehicle of mass 450 kilograms. So weight is 450 G. The angle is theta. Okay, and then they say here the sine theta value is given to you at the instant when the vehicle is moving down the road at 12 meters per second. So basically here the vehicle is moving down at 12 meters per second. The vehicle is working at a rate of P watts. So basically if you have in watts, you understand that they're talking about power. Okay, so you have a power here. Basically the vehicle is moving down the road. It's working at a rate of P watts. The acceleration of the vehicle is 0.5. So this is also accelerating. So they've given you the vehicle at that instant. Okay, the velocity, they have given you the velocity of the vehicle at that instant. So this is the acceleration 0.5 meter per second square. The resistance to the motion of the vehicle is modeled as a constant force of magnitude R. So the resistance is R. So I'll put it, resistance is obviously acting backwards against the direction of movement. Okay, so then they've given you this, and then again they've given you another case, right? At the instance when the vehicle is moving up the road, that's another case. The engine of the vehicle is working at a rate of 2p, the deceleration is 0.5, the resistance to the motion is R. They are asking you to find the value of p. Okay, so there are two instances that we need to consider here. The second instance, it's the same road, the theta is the same. So now in the second instance, the vehicle is moving up the road. The vehicle is moving up the road at 12 meters per second. And the deceleration of the vehicle is 0.5. So when they say use the word deceleration, what do you understand? So the vehicle is moving up. The deceleration means what do you mark for the, how do we mark it? But deceleration of 0.5 means the acceleration is how much? minus 0.5. Okay, the deceleration is 0.5 means the acceleration is minus 0.5. The resistance to motion of the vehicle from non-gravitational force is modeled as a constant force of magnitude R. So this time the resistive forces will be acting against. So it's going up, it will be this to this side. Resistive forces are, they are asking you to find the value of P. So here also I have the weight. So the weight is 450 G. Okay, so first let's work with the first case. So in the first case, let's work with this one. At the instant when the vehicle is moving down, let's consider the case where the vehicle is moving down. So first of all, you need to realize if the vehicle is having a rate of P watts here. So how do we get the power? What is the equation we use for power? Power equals to what?
Driving force.
Yeah, not just any force, but the driving force. Power equals to the driving force into velocity. Okay, remember it's not any force, it's not resultant force. It's the driving force produced by what? The driving force produced by the engine of the vehicle. Because if the vehicle is moving to a certain direction, it's because the engine produces a driving force to that particular direction. So here we have the driving force to this particular direction. So make sure you mark it. This the driving force is acting downwards. Do you agree with me? So I said D1 because we have two cases here. D1 and then let's input the value here. The power is P. Driving force is D1. Velocity is 12. I think you can see. If I want to find this value of P, I'll need to find the value of this D1. The driving force needs to be found, right? How do I find the driving force? Obviously, we'll have to use what?
F equal M.
F equal ma. We need to use F equal ma in the direction that the vehicle is moving. Okay, so if I'm using F equal ma along the plane, I think you can see D and R are on the plane. The resistive force, so I'll need to resolve the 450 G. So how does the 450 G resolve? So perpendicular to the plane, we get 450 G cos theta. And parallel to the plane, we get 450 G sin theta. Is that okay? And what else do I have? There's one more force that you need to mark here. Who is that? Friction we marked. Normal reaction. So for normal reaction in this situation, I will use the letter N or use some other letter because we have already used the letter R. So it's normal reaction. Okay, so these are the forces we have. So then what the object is moving down along the plane, I'll use F equals ma along the plane downwards because the object is moving down. So what is the, how do we use F equal ma here? D1 plus 450 G sin theta. Do you agree? These two are acting now. Opposing that is your resistive force. Minus R equal mass is 450 into acceleration is 0.5. Do you agree with me? So, so this is our first equation. Shall we input the sin theta value? D1 plus 450 G sin theta was 1/15, right? Minus R equals 450 into 0.5. So by the way, yeah. So I come to this point. Do you agree with me? Can I know the 450 divided by 15 answer?
225.
225. 450 into 0.5 answer?
295.
This answer? 450 into 1/5, 1/15 is sorry, that's wrong. You've given me the answer with G. That is, show me the answer again. That's 30 G, okay. 450 into 0.5 is 225. 225, okay. Okay, so I get this. So, similarly, I had to create another equation for this diagram as well, and I need to solve those diagrams. I need to solve those equations simultaneously, and I need to find the value of P. I think it's best if we replace the D value here as well, right? Okay, so we'll replace the D value. Who is D here? D equals to P over 12. Is that okay? Shall we take the 30G also to the other side? P over 12 minus R equal to 225 minus 30G. How much is the answer? 225 minus 30G should be 9.8. Gives me 225 minus 30G is minus 69. Of course, simplification is entirely up to you, okay? You can simplify in the way you like. So I just took it in this manner. Okay, let's go for the other equation also for the next diagram. The object is, the car is now moving. The vehicle is now moving up the road. So now the driving force is acting which way? In this situation, the driving force is acting up because the vehicle is moving up. So this time I'll use D2, the different driving force. Okay, so here also you have your normal reaction. I think you can see normal reaction. There's not a big change here. There's no big change in the normal reaction here. Because the resolving of 450G is exactly the same. So what do we get here? 450G cos theta and parallel to the plane I get 450G sin theta. Is that okay? Okay, then here also they have told you the rate of working. The rate of the engine is working at a rate of 2 p watts. So let's write power equal driving force into velocity. So power is 2p. Driving force is D2. Velocity is how much? Again, they said the velocity is 12. The velocity is again 12. So driving force D2 is 2p divided by 12, which gives me P over 6. Which gives me P over 6. Okay, let's use F equal ma. In this case, the object is moving up. So we will use F equal ma along the plane upwards because the object is moving up. So what do we have here? D2, yeah, minus R minus 450G sin theta, isn't it? Both of these are resisting the driving force. So D2 minus R minus 450G sin theta is equal to mass is 450. And what about the acceleration? We just wrote our acceleration is negative 0.5 meters per second square. Okay, so then let's input the values here. D2 we found it as P over 6 minus R minus 450G sin theta is sin theta was 1 over 15 equals 415 to minus half. 415 to minus half will be minus 225. So shall we simplify? Because we are going to end up getting a pair of simultaneous equations here. Do you see? And that gives us the values of P. That will give us the answer for P. We're supposed to find it. Shall we take this minus 450G into 1 over 15 to the other side? What do we get here? P over 6 minus R equals minus 225 minus 225 plus, because this 450 goes to the side as a plus 450 into G is 9.8 into 1 over 15. So I gave the whole thing. Okay, minus 225 plus 450 into 9.8 into 1 over 15. And I get here 69. Is that okay? This 69. Are you all okay with it? This equation, shall I multiply? I think we need to find the value of our R. I mean, not R. We need to find the value of P. So what you could do is, these are your two equations. So you can solve these two equations simultaneously in any way you like. You can subtract it, you can add it, you can subtract, you can do anything you wish here. Okay, so if you subtract the two equations, I think you can see R will cancel out. Okay, so anything. Or else you could use R, substitute R from here and use it over here, anything. Okay, the way you simplify is entirely up to you. So I'll do my R, the subject P over 12 plus 69 equals to R. I made R the subject here, taking these to the other side. So I'll substitute here. P over 6 minus R is P over 12 plus 69. Is that okay? Equals 69. So P over 6 minus P over 12 minus into plus 6 minus 69 equals to 69. Simplify. P over 6 minus P over 12 gives you how much? 1 over 6 minus 1 over 12 is? 1 over 6 minus 1 over 12 is 1 over 12. So 1 over 12, and don't forget the P equals 69 plus 69. So I get here P equal, what is 69 plus 69? 138, right? So 138 you multiply with, it's 1 over 12P, so you multiply it with 12. How much is 138 times 12? 1656 watts. So this is the power. So this is 1656 watts. So they're asking you to find the value of P, right? Yeah. So this is the value of P in watts, right? Yeah. Find the value of P. You could also leave your answer to 2SF or 3SF, okay? Because that's something they ask you to do in a normally when you give the numerical answer in the paper. They would tell you to give your answer in 3SF. So we can write the answer as 1660 watts. Or in other words, you could leave your answer as 1.66 kilowatts. When you divide by 1000, you could leave your answer in this manner as well. Okay, so all of these answers are okay. Question number 3, a particle P moves on the x-axis. At time t equals 0, P is instantaneously at rest at O. So basically they've told you at time 0, it's instantaneously at rest means the velocity is 0. It's at O means your displacement is also 0. At time 0, velocity is 0 and displacement is 0. At time t seconds, where t is greater than 0, the x-coordinate of P is given by this formula. Find the non-zero values of t for which P is at instantaneous rest. Okay, when we talk about instantaneous rest, obviously what do we think about? I mean, when you are at rest, who is, what do we consider? Which person do we consider? We consider velocity. And when you are at instantaneous rest, your velocity will be 0. So basically what you do is you take a displacement equation and you create your velocity. How do you create the velocity? We differentiate. X equal to t to the power 7 over 2 minus 14 t to the power 5 over 2 plus 56 over 3 t to the power 3 over 2. But then let's differentiate. I get here dx by dt, isn't it? 2t to the power 7 over 2. So when you differentiate, 2 into 7 over 2 is 7. T to the power 7 over 2 minus 1 is 5 over 2. Is that okay? Minus 14 into 5 over 2 is how much? 35, right? 35 t to the power 5 over 2 minus 1 is 3 over 2. Plus 56 over 3 into 3 over 2 gives me how much? 28 t to the power 3 over 2 minus 1 is half. Okay? Okay, so then we'll continue simplifying. Dx by dt is our velocity. And velocity reaches at instantaneous rest. Velocity will be 0, right? How do we simplify this? 7t to the power 5 over 2, 35 to the power 3 over 1, 28 to the power half. I hope all of you are clear about the 7 here, right? How the 2 became 7? Because 2 multiplied with the 7 over 2. When we differentiate, we took the power in front, right? Because and then we subtract 1 from the power. So that's how all these values came at this point. Now, what you need to do is take the common thing out. Like for example, you could say here 7 is common. And also what is common? T to the power. Like we could see here the t to the power half is something that we can take out. Now a common mistake that many of you do when you take t to the power half out is like you would say think of this as t to the power 5. Isn't it? You would see like okay, I take t to the power half out, so this should be t to the power half, t to the power 5. You would think of this as t to the power 3. Okay, so that's not correct. What we do here is when you take out t to the power half, basically what you're doing is you are dividing by t to the power half. Basically, if you take out the t, now here I have 7t to the power 5 over 2. When you're taking 7t to the power half, it means you're dividing by 7t to the power half. Here we have minus 35t to the power 3 over 2. You divide by 7t to the power half because that's what you're taking out. Whatever you take out, you need to divide by that particular figure. 28t to the power half, you divide by 7t to the power half. Are you with me? So what do we get here? The 7 and 7 cancels. T to the power 5 over 2 divided by t to the power half. Powers will subtract. 5 over 2 minus 1 over 2 gives you how much? 5 over 2 minus 1 over 2 is 4 over 2, which is t square, power 2. Minus 35 divided by 7 is 5. T to the power 3 over 2 divided by t to the power half. Subtracting powers. 3 over 2 minus 1 over 2 is 2 over 2, which is 1. Sorry, 5 t to the power 1. Plus 28 divided by 7 is 4. T to the power half, t to the power half cancels. Do you see this? So I get here 0 equals 7t to the power half. I think this particular quadratic equation can be further factorized. It becomes a t minus 1, t minus 4, right? T minus 1, t minus 4. So basically, I get here the factor 7t to the power half is 0 or t minus 1 is 0 or t minus 4 is 0. Basically, t to the power half equals 0 or t is 0. I think we already have that because we know the object is an instantaneous rest at O at a time 0. So that is not what they want. They want time where the non-zero values of t. So this is not what we want. We need the other values. So the other values I have here, t equals 1. Here the other value I have is t equals 4. Okay. So these are my two non-zero values of t for which t is at an instantaneous rest. Is that okay? Okay, part B, find the total distance traveled by P in the interval 0 to 4. So once again, what is it? Total. The key word here is its total distance. Are you with me? We need to find the total distance. Now, by the way, you can see we have the equation for x here. Now, we already have found the equation for velocity and we have the equation for x. X gives you the displacement. Starting from the origin, it gives you the displacement. So, you're supposed to find not the displacement, but the distance traveled by the particle in the interval 0 to 4. Okay, so this is a little bit, you need to think a little bit more about this. You need to think a little bit more here. Now, thing is, you need to definitely use the help of your part A. Look at part A. In part A, what did we find? We found the t values that makes you what? That gives you the values where your particle is instantaneously at rest. Are you with me? It gives you the values where your particle is instantaneously at rest. So I think you can see here in this particular equation, the velocity equation. Have a look at your velocity equation. We need to kind of get a rough idea of what's going on. It's 7t to the power half into t minus 1 into t minus 4. So you know all your t values are positive here. So have a look at what's going on. How will your velocity time graph look like? So basically you can see here now if I consider only these two parts, okay, this of course 7t to the power half is a positive figure. Okay, but here do you see when you take these two parts that you kind of like get a quadratic equation. That the quadratic equation, the cutting points were at where t equal 1 and t equal 4. So you kind of get a quadratic equation like this, right? Do you see what's going on here? The velocity, how the velocity function will move. I mean, this function, these y values will be multiplied with 70 to the power half. Okay, but however, the main thing here is that these values are following kind of like this quadratic pattern, which means from 0 to 1, you have what kind of a displacement? From 0 to 1, you expect a positive displacement. Do you see what I'm talking about? And from 1 to 4, you expect a what displacement? A negative displacement. This is the important thing. So then when you're using this equation, the x equation, all you need to do is to get the distance from 0 to 4. You can't do this immediately. What you do is first you get the displacement from 0 to 1. And then what do you do? Then you get the displacement from 1 to 4. Are you with me? So I'll use here the displacement, the x. Directly I have my x. So I'll give the limits for x because I can give the limits and get the area I want. So for x, I'll first go for x from 0 to 1. And then I'll go for x from where to where? From 1 to 4. Do you see what I'm talking about? From 0 to 1, I expect to see a positive answer. And from 1 to 4, I expect to see a what answer? Definitely it's negative. And then to make it distance, I just have to ignore the negative and add the two displacements without taking the negative sign. Are you with me? So shall we input the limits now? So 2t to the power 7 over 2 minus 14t to the power 5 over 2 plus 56 over 3 t to the power 3 over 2. So input the limits 0 and 1. 2t to the power 7 over 2 minus 14t to the power 5 over 2 plus 56 over 3 t to the power 3 over 2. Here the limits are from 1 to 4. Is that okay? So I'm writing everywhere. Just be careful. Okay, you're not supposed to write on this. Okay, what do we get here? When t equals 1, can you all substitute? I get here when t equals 1, I get here 2. 1 to the power 7 over 2 is 1. Minus 14, 1 to the power 5 over 2 is 1. Plus 56 over 3. Is that okay? This is the first limit. Minus the second limit is you replace all your t values with 0. Is that okay? Plus, we'll add the second limit. So input 4 and 1 here. 2 into 4 to the power 7 over 2 minus 14 into 4 to the power 5 over 2 plus 56 over 3 into 4 to the power 3 over 2. Is that okay? This is the first limit. Subtracting with the second limit. You can directly write these answers. Input 1 here. 2, 1 to the power 7 over 2 is 1 minus 14, 1 to the power 5 over 2 is 1 plus 56 over 3, 1 to the power 3 over 2 is 1. Okay, can I know the value here? 2 minus 14 plus 56 over 3 gives me 20 over 3 from the first bracket. I think the second bracket I will definitely expect to see a what answer. From the second bracket I will definitely expect to see a negative answer because it's from 1 to 4 and my graph says that it will be negative. So I get here 2 into 4 to the power 7 over 2 minus 14 into 4 plus 56 over 3 into 4 to the power 3 over 2. Sorry, I have not given the power here. 2 into 4 to the power 7 over 2 minus 14 into 4 to the power 5 over 2 plus 56 over 3 into 4 to the power 3 over 2. This gives me minus 128 over 3. Are you okay with that? The first bracket is minus 128 over 3 inside the, and then here the next part 2 minus 14 plus 56 over 3 will be 20 over 3, right? Because that's the value I just got earlier. It's the same thing again. So I get here the displacement. This 20 over 3 is the displacement from 0 to 1. 20 over 3 is the displacement from 0 to 1. This guy minus 128 over 3 minus 20 over 3 gives me minus 148 over 3. Do you see this? Do you see this? And then you can see that's the negative displacement. That's the displacement we have from 1 to 4. This was definitely, I expected this to be negative. So what should I do here? Since I want distance, I want the positive and the negative. I want everything. Okay, so then what we do here is we do not take the negative value. We take the modulus of this value here because I want the distance. Do you understand? If I add this just like this, I get the displacement. So 20 over 3 and don't take the negative sign. Take the positive figure of 148 over 3 because I want the distance. So 20 over 3 adding with 148 over 3 is 56. So the answer is 56. Okay, so this is our distance. Is this clear? Part C, the acceleration of P when T equals 4. How do we find the acceleration? Obviously, what we need to do here is we have the differentiation of x and we got the velocity. Can you see the velocity function? We will go with this, right? The simplest form. instead of taking the more factorized form because it will be difficult to integrate, velocity to acceleration, we will differentiate. So to differentiate, I don't want the factorized form. I want the format where it's all everyone is open and everyone is separately located. So they're asking me to find the acceleration when t equals 4. Okay, so let's differentiate, get the acceleration, replace t with 4. Part C, so velocity is 7t to the power 5 over 2 minus 35t to the power 3 over 2 plus 28t to the power half. Are you with me? Let's differentiate and we get dv by dt. So let's differentiate 7 into 5 over 2. 7 multiplied by 5 over 2 is 35 over 2. T to the power 5 over 2 minus 1 is 3 over 2. Is that okay? Minus 35 into 3 over 2 gives you how much? 35 into 3 over 2 gives you how much? 105 over 2t. 105 over 2, 30. 3 over 2 minus 1 is 1 over 2. Half. 28, when you multiply with half, 20 into half is 14. T to the power half minus 1 is minus half. Is that okay? So this is my dv by dt and I have to find basically my acceleration and I have to find the acceleration when t equals to 4. So when t equals 4, acceleration becomes 35 over 2 into 4 to the power 3 over 2 minus 105 over 2 into 4 to the power half plus 14 into 4 to the power minus half. Type this all in the cal and let's see the acceleration we get. (35 over 2 into 4 to the power 3 over 2 minus 105 over 2 into 4 to the power half plus 14 times 4 to the power minus half, and I get my acceleration answer as 42. This is my acceleration answer, 42. This is in, yeah. Question number 4, a particle P of mass 0.75 kilogram is moving with velocity 4i meters per second when it receives an impulse j Newton seconds. Immediately after P receives this impulse, the speed of P is 8 meters per second. They've given you the speed immediately after, not the velocity. How they've given you that the impulse j is given as c times minus I plus 2j, where c is a constant. Find two possible values of c. Okay, first things, what do we do here? Immediately the equation that comes into our mind is the impulse equation. So what's the impulse equation? I equals mv minus mu, isn't it? So impulse is given to you as c times I minus I plus 2j, which means minus ci plus 2cj. So this is my impulse. Mass is 0.75. Do we know the final velocity, by the way? They have given you the final, after the impulse, they've given you the final speed. You must understand that speed and velocity, are they the same? No, speed is a scalar while velocity is a vector. So I'll leave the velocity v in this form, the final velocity. You should not input this v as 8. Okay, you should not input this v as 8. It's totally wrong. Because here the v represents velocity, not a speed. So mv minus mu. U is given in terms of ij. So they've given you u is 4i. And that means it's 40. 4i means it's 40. Okay, then let's take this here minus c, 2c, and I get here plus. I get here. Okay, before I do that, yeah. We can take this here. 0.75 times 40. Are you with me? Equals 0.75 v. What I'm trying to do here is I'm trying to make v the subject now. So this is not c over 2c. This is minus c 2c, the vector, velocity vector. So can you multiply this 0.75 with 4? 0.75 into 4 is 3, right? 0.75 into 0 is 0. Here again 0.75 is 3 over 4, right, as a fraction form. So when I add this, I get here minus c plus 3 over 2c is equal to 3 over 4v. Are you with me? The final velocity is equal to 4 over 3 times minus c plus 3 2c. This is not a fraction, this is the velocity vector. So when I write in the proper form, velocity vector equals to 4 over 3 times minus c plus 3i plus 4 over 3 times 2cj. Are you with me? So this is my velocity vector. So then I have this in now. I now have my final velocity in terms of ij. What's my next step? I have the final speed, right? They've given me the final speed as 8. So then since I have the final velocity vector in terms of c here, how do I convert the velocity to speed? Take the, how do I convert velocity to speed? I have to get the magnitude of the velocity, right? So that gives me the speed. So speed equals to 4 over 3 minus c plus 3. You square your components, right? I square, this is 4 over 3 into 2 is 8 over 3. 8 over 3c. So this guy is square. And the square root of the whole thing is the speed. So speed is 8. I'll remove the large root by taking this side as a square. I remove the large root. And I end up getting here 4 over 3. Inside the root, I have here 4 over 3 minus c plus 3 square, which gives me 16 over 9 minus c plus 3 square. And I get here 8 over 3c when I square it. 64 over 9c square. Are you with me? So it's now actually a quadratic equation. You just need to open the bracket, solve the quadratic equation and get your answer. Okay, so this is 64. I think I'll multiply the whole equation with a 9. Is that okay? So here 64 times 9. And I get here 16 times minus c plus 3 square plus 64c square. Do you agree with me? 64 times 9 gives me? That gives me 576. 16 times minus c plus 3 square. You'll have to expand the bracket. Minus c plus 3 into minus c plus 3 is c square minus 6c plus 9. I immediately expanded. 64c square. Let's get the answer. 576 equals 16c square. 16 times 6 is? 16 times 6 gives me 96c plus 16 times 9 gives me 144 plus 64c square. Do you agree with me? 576 equals, at the like term, 16c square plus 64, 80c square. 80c square minus 96c plus 144. Take the 576 to other side. Take it to the other side. 144 minus 576 gives me minus 432. Is that okay? This is okay. Did you come to this point?
Right.
This equation we can further simplify. I think you can see the whole thing is divisible by 8. Okay, you can try and see. Actually, the whole thing is actually we can go for a larger number. We can divide the whole thing by 16. So 80 divided by 16 is 5. 5c square. 96 when you divide by 16 we get 6c. 432 when you divide by 16 we get 27. Okay, so then we can factorize now. What are our two factors? We get here c minus 3. The other factor is 5c plus 9. Am I correct? Then we get here c equals to 3 of c equals to minus 9 over 5. Okay, so these are our answers for the values of c. Okay, find the values of C. Okay. So two possible values of C. Question number 5. A pole AB has length 2.5 meters and weight 70 newtons. The pole rests with NB against a rough vertical wall. Okay, so this is the pole. It's leaning against a rough vertical wall. One end of a cable of length 4 meters is attached to the pole at A. The other end of the cable is attached to the wall at the point C. The point C is vertically above B and BC is 2.5 meters. Okay, so you can see the diagram, it's, everything is marked very clearly, right? The angle between the cable and the wall is alpha, as shown in figure 2. The pole is in a vertical plane perpendicular to the wall. Okay. It's in a vertical plane perpendicular to the wall. Okay. The cable is modeled as a light inextensible string and the pole is modeled as a uniform rod. So if your pole is modeled as a uniform rod, what do you realize? You realize that the weight acts at the weight acts at the what? Center. Okay, so let me take this figure. Enlarge this a little bit. Okay, and let's mark all our forces. So first thing is, I'm gonna mark the weight, which is how much? Which is 70 newtons. Already directly weight is given as 70 newtons. Okay, they've told you tan alpha is 3/4. So from tan alpha, you can find what? Sin alpha and cos alpha, isn't it? Tan alpha to opposite over adjacent, which means the hypotenuse is 5. So sin alpha is opposite over hypotenuse. Cos alpha is adjacent over hypotenuse. Is that okay? And they're asking you to show that the tension in the cable is 56. Obviously, to do this, the first thing you need to do is what? You have to mark all your forces. So what are all the forces acting on the pole AB? First thing they say to you is that the pole is resting on a rough wall. So at B, you have a rough wall. And again, also this pole is held in equilibrium because they are attaching it to a cable. You see there's this cable here. Okay, so then obviously when it's attached to a cable, what do we have here? We have tension. We have tension. Equal opposite tension will act on the wall. I'm only concerned about the forces acting on what? I'm mainly concerned about the forces acting on the pole. Okay, what else is there? What are the other forces acting on this pole? What are the other forces acting on this pole? Normal reaction, which will act what? Perpendicular to the surface that you are touching. So then at point B, you have normal reaction perpendicular to the wall. And what else do we have? We have what? The other force is friction. So since you can feel like obviously when it's in this particular form leaning against the wall, the tendency is for this to fall down, right? The pole trying to fall down. So therefore friction will say it acts up. Okay. Okay, then let's get the value of the tension in the cable. How do I find the tension in the cable? How do I find the tension in the cable? Moments. We'll consider moments about where? Who is the best place to consider moments? A. If you take moments around A, you need to consider both F and R. No, we'll take moments around what? B. If you take moments around B, then you need to only deal with the 70 newton and the P. That's all. Let's take moments around B. So I'll take clockwise as positive. Okay, so then the next thing is you need to work now. The next important thing is you need to work with these angles. Okay, how do we work with these angles? So 70 Newton. What's the perpendicular distance from 70 Newton to point B? How do we find the perpendicular distance from 70 Newton to point B? So for 70 Newton, I'll draw the line of action. So this is my line of action, right? For 70 Newton, what's the perpendicular distance between B and 70 Newtons? It's this short distance, right? I think you can see. Okay, now the thing is how to get the short distance. Now you do realize AB is 2.5 meters, isn't it? AB is 2.5 meters. Since it's a uniform rod, the weight acts at the center. Can I know the half of 2.5? Okay, so we need to get the perpendicular distance from the 70 Newtons. Okay. So how do we get the perpendicular distance from 70 newtons line of action to the point B? Then how do we get it? The first thing is now they have only marked us one angle here as alpha, isn't it? So how can we find the angle that we need here? Okay, the first thing that I do here is I notice this is a what triangle? This is an isosceles triangle, isn't it? 2.5, 2.5. So which means the angle alpha, angles at the base of an isosceles triangle are equal, meaning this angle is also alpha. Do you agree with my working? It's also alpha. And then I'm also going to use one more thing here. What if I mark this vertical here at the point A? Do you notice that this vertical and this, we can create an alternate angle here? The verticals, the two verticals, CB line and this vertical line, they are parallel. So basically I create an alternate angle here. Do you see that? Which means this angle is also an alpha. Do you agree? And then I could use alternate angles from here over to here. Just have a look at this. Do you see the letter Z at this point? Which means what? This angle will be how much? 2 alpha. So now I can get the perpendicular distance from 70 Newton to point B. Isn't it? From 70 Newton to B, do you agree that the perpendicular distance is what I'm marking right now with this blue color? Do you see this distance that I'm marking? Isn't this the perpendicular distance from the line of action of 70 to point B? This is the perpendicular distance, right? So that distance I can find. The same distance I can get it down over here, isn't it? So then can you see that I just have to complete this triangle? So half of 2.5, how much did you say? It's 1.25, right? So 1.25, what is it? It's not cos. Cos is vertical. 1.25 sine 2 alpha. Do you see? This distance is 1.25 sine 2 alpha. Do you see it? So when you take moments around B, 70 Newton is pulling this down, isn't it? Which means 70 Newton gives a what moment? 70 Newton gives a what moment?
Clockwise.
Gives a clockwise moment. So I'll write minus here. Because I'm taking clockwise is positive, what I've chosen. So clockwise, 7 Newton is anti-clockwise, isn't it? Why would you say it's clockwise? 7 Newton is pulling this backwards. Around B, 70 Newton gives an anti-clockwise moment. So clockwise moments are what I've considered as positive. So minus, what do we get here? 70 into, what's the perpendicular distance? 1.25 sine 2 alpha. Is that okay? Minus 70 into 1.25 sine 2 alpha. Okay, we are done with that. Now the next force we need to consider is what? The next force I need to consider is the tension. Okay, so either what we could do is you could find the perpendicular distance from the tension's line of action to point B, or else you could resolve your tension into two components and find the perpendicular distance to both. So I think you need to realize if you do resolve your tension, so you get the chance of, you will have to work with two forces instead of working with one. Because if you do resolve, you'll get your T cos alpha, and to the other side, you'll get T sin alpha, isn't it? You resolve with this angle as the main angle. So T cos alpha will be vertical, T sin alpha will be horizontal, which is two components to consider. And you need to get the distance from both of them to point B, which will both give two separate moments. So why don't we go like this? Instead of going for resolving P, why don't we consider the line of action of T? So doesn't T's line of action goes like this, right? So can't we find the perpendicular distance from point B to the line of action of T? Do you see that I have an isosceles triangle here? So if basically if I want to get the perpendicular distance from this line of action of T to B, do you see it's because it's an isosceles triangle, it's just this distance that directly comes like this. From the isosceles triangle, it's directly the perpendicular you drop exactly into the middle here. It's this distance, right? So basically this green color length I marked here. This is the distance. This is the perpendicular distance from B to the line of action of T. So can't we find this particular distance? Can't we find this particular distance? So this is 2.5 and then this is 90 degree. You could resolve, right? It's 2.5 to this side. It's 2.5 cos alpha. Do you see the right angle I'm referring? Let's say this is point X. So if I take AXB, so if I take AXB, this is 2.5, it's not, yeah, this is 2.5, this is the alpha. So basically the XB distance is the perpendicular distance, right? So it's 2.5, not cos alpha, 2.5 sin alpha is the perpendicular distance. Do you see? So this XB distance is 2.5 sin alpha. Is that okay? And that gives a what moment, by the way? The tension gives a what moment around B? So I think you can see the tension gives a what moment? Through point B, this is pulling up, it gives a clockwise moment. Can all of you see it gives a clockwise moment, which means it's a positive T into tension into the distance is 2.5 sin alpha. Is this clear? So these are the moments, these are the only two forces and these are the two moments we get. And the sum of moments must be equal to 0 because the figure is in equilibrium. Because this particular object is in equilibrium. So I took the moments around B for the pole. Okay, so the cable is not the main objective, the pole is the main object. They have given the weight of the pole and they've said the pole is resting on this rough wall. So we mark all the forces acting on our pole, take moments around B and we take moments around B. The only forces we need to consider are its own, the pole's weight and the tension acting on the pole. Okay, so now it's a matter of simplifying and making what? Making T the subject. So how do we make T the subject here? I think I've already calculated sin alpha here. You do realize we have sin 2 alpha, which is sin double angle rule. So sin double angle rule is what? So I've written here the double angle rule for sin 2 alpha is 2 sin alpha cos alpha, isn't it? So shall we use it over here? Input our sin alpha cos alpha values and make T the subject. Minus 70 into 1.25 into sin 2 alpha is 2 sin alpha cos alpha. Plus T into 2.5 sin alpha. Shall I take this entire negative term to the other side? T into 2.5 sin alpha. Minus 70 becomes plus 70 into 1.25 into 2 sin alpha cos alpha. That is sin, we can remove 70 into 1.25 into 2 sin alpha cos alpha. Divide by 2.5 sin alpha. This sin alpha would remove, right? Input the value for cos alpha, get the answer. Cos alpha is 4/5. Get the value of tension. And I get T is 56. So my answer is T equals 56, which is the show that. Do you see? Part B. Given also that the pole is in limiting equilibrium, find the coefficient of friction between the pole and the ball. Okay. So they want us to find the mu value that acts at this point. Okay. So how do I find, let me erase these irrelevant things. Okay, how do I find the mu value here? How do we find the mu value? What do? We need to consider after considering moments. We have already considered moments. We found our T value. Now what we do is what? The next thing we do for equilibrium is, now they say they do use the word here, what equilibrium? Limiting equilibrium. So what is the difference between normal equilibrium and limiting equilibrium? In limiting equilibrium, your object is about to move, which means you have what? You have maximum friction. So that's the difference in normal equilibrium and limiting equilibrium. In just equilibrium, the friction is less than or equal F max. While in limiting equilibrium, the friction you have is directly the F max. So basically, F max means you have what friction? You have the mu r friction. You have the maximum friction or the mu r friction here. Okay, so what we'll do here is the next step that we need to do here is consider what we'll be taking the vertical equilibrium and horizontal equilibrium. So I think that is easy. So I'll do here, I'll take vertical and horizontal. Taking T and the angle alpha to the vertical, I can resolve T up as what? Taking T and the alpha which is to the horizontal, which is to the vertical. Taking T and the alpha which is to the vertical, this can be resolved as T cos alpha, and taking T and alpha to the, with the same angle alpha, I'm using this angle alpha here, okay? Using this angle alpha, I have here T cos alpha. Using that same angle, I get the other side T sin alpha. Are you with me? Shall we use horizontal and vertical equilibrium? So when I use vertical equilibrium here, what do I get? So for vertical equilibrium, what do we have? T cos alpha plus the maximum friction, isn't it? T cos alpha plus the maximum friction is equal to what? Is equal to 70 newtons. So T cos alpha, we know the T value is 56, right? Cos alpha was found to be what? 4/5. So cos alpha is 4/5. T cos alpha plus friction. F max is mu r equals 70. So actually mu and r values are what I need to find. Mu value is what I need to find. Let's take the horizontal equilibrium. So considering the horizontal equilibrium, so what do we get for the horizontal equilibrium? You can see for horizontal forces, I have the normal reaction, which is equal to what? Normal reaction will be equal to T sin alpha. Do you agree? Normal reaction equals T sin alpha. So input the values. T is 56, sin alpha is 3/5. 56 into 3/5, how much is it? I get 168/5. Yeah, 33.6, isn't it? So then let's input that R value here and what? Make mu the subject. So 56 into 4/5 plus mu into 168/5 equals 70. So how much is 56 into 4/5? That gives me 224/5 plus 168 mu/5 equals 70. 168 mu/5 equals 70 minus 224/5, which gives me 126/5. Is it okay? Okay, so then mu value will be 126/5 into 5/168. Simplify, type this in the cal, and I end up getting how much? Mu is 3/4. Is that okay? 126 divided by 168. Yeah, 3/4. So this is my mu value. Okay. Okay, question number 6. Two particles A and B are moving in opposite directions along the same straight line on a smooth horizontal surface when they collide directly. The mass of A is 2m and the mass of B is 3m. That's right. So you have two particles here, A and B. The mass of A is 2m and the mass of B is 3m. Two particles A and B are moving in opposite directions along the same straight line on a smooth horizontal table. So when they collide directly, they are moving in opposite directions means to collide, and to move in opposite directions means they must come like towards each other, isn't it? Opposite directions and collision means they need to come towards each other. Then they say here immediately after the collision, A and B are moving in opposite directions. So after the collision, they are moving in opposite directions, which means you definitely realize that they both turn back with the same speed v. So both of them have the same speed v. Are you all with me? So they say in the collision, A receives an impulse of magnitude 5 mv. So the impulse, what do we know about the impulse? The impulse received by A is in what direction? When A and B collide, the impulse received by A is in the backward direction, while the impulse received by B would be in the forward direction, isn't it? That's the rule when they collide. Okay, this is something you learn in M1. They say in the collision, A receives an impulse of magnitude 5 mv. You know, impulse on A, impulse on B. Now, though they say here impulse on A, does it mean that it's any different for the impulse on B? No, these are equal and opposite forces. So basically, both of these impulses are 5 mv. Not only on A, but the one on B as well. Okay. So in the collision, A receives an impulse of magnitude 5 mv. Find the coefficient of restitution between A and B. They want you to find restitution. I think before we go for restitution, what do we need to do here? We need to find the two initial speeds. So let's take our two initial speeds as x and y, or you can say just use two letters. Okay, so then what we'll do here is I'll use I equals mv minus mu. I'll use it on A first. And when you're using it on A, what do we do here? We need to consider backwards as positive, because the impulse on A, the backward direction is positive. So then in here, I equals mass is 2m, isn't it? Final speed v is v, that is backwards, minus mass is 2m, u is x, which is forward. Do you see? So I is backwards, it's 5mv. 2mv, I don't need to change directions because it looks okay, the direction here. 2mx, the x is to the forward direction. I need to convert it backwards, which means this will be minus, I had to input another minus, which gives plus 2mx. Do you see what happened here? The minus mark here became plus because I turned the arrow to the other side. Okay, so now everyone is to the backward direction. Do you see? So now you can cancel out them. We get here 5v equal 2v plus 2x. 5v minus 2v is 3v equals to 2x. So x equals to 3v over 2. Agreed? X equals to 3v over 2. Next we apply I equals mv minus mu on b. When you apply to b, what happens? When you apply I equal mv minus mu on b, impulse on b, the impulse is to the forward direction. So this time the forward direction is your positive direction. So then the impulse is 5mv. The mass is 3m. Final velocity v is to the forward direction. Isn't it? V is to the forward direction, isn't it? Minus mass is again 3m into initial speed is what? Y. Initial speed is y, which is the backward direction. So we get here 5mv, 3mv. This I have turned to the other side, plus 3m. This is, I just use the multiplication sign here. So 3my. Okay. And then I turn this plus because I turn the arrow to the other side. So therefore the negative becomes positive. Okay, do you agree with me? So I cancel out the m. And I get here 5 minus 3 is 2v equals 3y. And I get y equals 2v over 3. Is that okay? I get y equal 2v over 3. Okay, so now I have the two initial velocities of the two particles. Now what do we do? Now I have the two initial velocities in terms of v. Isn't it? So now since everyone, now my initial velocity, final velocity, everyone is in terms of v. What do? Now we can go for the law of restitution. So by Newton's law of restitution, we know E equals to speed of separation over speed of approach. So V1 minus V2 over U2 minus U1. You need to change the sides here. V1 minus V2 over U2 minus U1. You have to switch the order. You remember here? We need to switch the order. So E equals V1 minus V2. So I'll use V this way. I'll say this is V1, V2. So obviously this should be U1, U2. Okay, U1 is X, U2 is Y, V1 is V, V2 is also V. So here V1 minus V2 is also V. The directions are on two different sides. Divide by U2. Who is U2? U2 is Y. U2 is Y minus U1. U1 is X, which goes forward. You have to convert everyone to one particular direction. So I'll choose going to the right as positive. Shall we convert? So these people need to be converted. This negative one, these two backward directions, I have to convert to forward. So basically, I get here minus V, minus V over the Y becomes minus Y minus X. So let's input the value minus 2V over minus Y will be minus 2V over 3 minus X is 3V over 2. Minus 2V divided by minus 2 over 3 minus 3 over 2 gives you how much? It gives me minus 13 over 6. Are you okay with that? Minus 13V over 6. So actually you can see minus divided by minus, I could remove it. 2V divided by 13V over 6. Which gives me, you can do these, remove certain steps. I'm writing some extra steps for everyone to understand, but if you do know do the short in the short way, please do. V to V cancels out and I get here what? 12 over 13 is our E value. Is this clear? Okay. Part B, after the collision with A, particle B strikes a smooth fixed vertical wall and rebounds. Okay, do you see what's happening here? So you have two particles. So you have two particles A and B. Okay, listen to this. So we have it like this, right? Initially we started off with what speed? Initially we started off with A started off with the speed 3V over 2 and ended up rebounding with V. Particle B started off with the speed 2V over 3 and ended up rebounding with V. Are you with me? And then what happens in the next stage? They say now particle A, of course, at this point, particle A is moving back, right? It's going back. The particle A is going back with the speed what? At the end of the day, particle A is going back with speed V, right? And what happened to particle B? It goes and hits this wall. Do you see it? It goes and hits the wall. So it hits the wall at what speed? It hits the wall at what speed? Because you can see after the impact, B received the velocity V. So the speed V. So B will go and hit the wall with the speed V. Isn't it? B goes and hits the wall with the speed V. And then they told you the restitution between B and the wall is F. The E value, the coefficient of restitution is F. So then when a solid object goes and hits a wall or a ground, what do we use for restitution? Directly the equation we use is impact between B and wall. For the impact between B and wall, we can use the restitution is what? F equals V over U. Do you remember what is V over U? V is the final over U is the initial. So if I use V over U, I think you'll be confused here. Final velocity or final speed over initial speed. So here the final speed is what? Final speed is what we consider as when we rebound after you hit the wall. So here let's say my so let's say here my final speed is V1. So final is V1 over initial is what? Initial is the speed which you go and hit the wall, which is V. Do you see? V is the speed you hit the wall. V1 is the speed you rebound, V1 is final, initial is V. So which means I get here what? V1 equals to Vf, which means what? Vf is the speed with which you rebound. The particle B rebounds with speed Vf. Are you all with me? Okay, so I found the speed of rebounding. Okay, now what do they want us to do? As a result of its collision with A and with the wall, the total kinetic energy lost by B is E. Okay, what do you mean by the total kinetic energy lost by B? Now, what did B start off with? What was the starting velocity of B? You saw that B started off with the velocity 2V over 3, right? So it has an impact with A, and then what happens? After impacting with A, obviously, you know, at every impact, you lose a little bit of your energy, right? Because the speed will drop. So then you go, it impacts with A, then it rebounds it rebounds, and then it goes and it again hits the wall. It hits the wall and it again rebounds. So basically, at the end of the day, what they are saying, I mean, you can see that there are two collisions here. At the end of the day, they say the total kinetic energy lost by B is E. So how do we get the total kinetic energy loss? We started off with what speed? B started off with the speed 2V over 3, and it's finally ending up with what speed? It's ending up with the speed V1, which is Vf. So can't you find the total kinetic energy lost by particle B? Total kinetic energy lost by B. How do I find the total kinetic energy lost by B? So I start off with the speed with which B started. Okay, so that is energy scalar by the way. Do we need to consider directions? No, energy scalar, directions are not necessary. We don't need to consider. I just need to get the initial kinetic energy and I need to get the final kinetic energy and just subtract. But what will I get? The difference gives me the lost energy. Okay, so half, what about the mass here? Particle AB, the mass is about 2m and 3m, right? So then half particle B mass is 3m into, how do we take the kinetic energy lost? So you started off with the speed 2v over 3, isn't it? Then minus with the final speed half m is 3m into final speed is vf. Do you see? So it's half into 3m. Shall I take it out? Half and 3m, I'm going to take it out. I get 4v square over 9 minus v square f square. Do you agree with my working? Again, I'm repeating, energy is a scalar quantity. Directions are not considered. All you need to do is to get the lost energy, get the initial energy, subtract from the final energy. Initially, I start off with this speed. Finally, I end up with V1. This is talking about the particle B. Particle B started off with 2v over 3 and ends up with V1, which is Vf. So then I used half mv square minus, I subtracted the kinetic energies at both these 2 points. Can you all simplify? 3 over 2m, I can take the v square out and I get 4 over 9 minus f square. Is that okay? Is that okay? So this is my total kinetic energy lost by B, which is how much? Total kinetic energy lost by B is E. They've given us the total kinetic energy lost by B is E. So this is the expression for E. Shall we make another expression for A? They've told you that as a result of its collision with B, the kinetic energy lost by A is 2E. So particle A is only having one collision, right? It initially started off with the speed 3v over 2. It has a collision with B and it rebounds. Are we having any other impacts about particle A? No. So they say as a result of its collision with B. They don't say any other thing. Like in particle B, B, they were saying it has a collision with A and a collision with the wall. There were 2 things. But in here, for particle B, it only collides with B. That's it. So then the kinetic energy lost by A is 2E. How do I get the kinetic energy lost by A? Kinetic energy lost by A. So we start off with the initial KE. What's the initial KE? Half mv square, which is what? Half mu square, 3v over 2. So this is the initial KE. Do you agree? What's the final KE? Subtracting with half 2m final kinetic energy is half m v square. Do you understand? I'll take half and 2m out. So I end up getting here 9v square over 4 square plus to every term minus v square. What do we get here? Half and 2 cancels. I get m times 9v square over 4 minus 1v square is how much? 5v square over 4. Is this correct? 5 over 4 mv square. So this is the KE lost by A. Do you agree with me? And this is equal to what? They have told you that the kinetic energy lost by A is how much? Here, look at the question. The kinetic energy lost by A is 2E. Okay, so now what do we need to do? Now substitute. We already found the value of E, right? In the earlier part, we found the value of E. So substitute. So 2 times E. What's E? 3 over 2 mv square into 4 over 9 minus f square equals 5 over 4 mv square. Do you agree with me? So what cancels here? M and v square cancels. Do you agree with my working? Do you understand what I did here? I took the E value in equation 1 and replaced the E over here. 2 times this E value over here is equal to 5 over 4 mv square. Okay? 2 to 2 cancels here. I get 3 times 4 over 9 minus f square equals 5 over 4. Open the, we can take the 3 to the other side, or you could open the bracket entirely up to you. I'll take it to the other side. 3 goes as a division, 5 over 12. So I'll take the negative f square here and I'll take this here. I want to find the value of f. 4 over 9 minus 5 over 12 equals to f square. This is okay. So 4 over 9 minus 5 over 12 gives me how much?
1 over 36.
Gives me 1 over 36 equals to f square, which means f is root 1 over 36, which is 1 over 6. Don't use plus or minus here because it's obvious that you are turning back here, right? And it's restitution, by the way. F is the value of the coefficient of restitution, which is definitely positive. E values are between 0 and 1. Okay? Okay, moving on to question number 7. In this question, you may use without proof the formula for the center of mass of a uniform sector of a circle as given in the formula book. Okay, so center of mass of uniform sector as given in your formula book is, so this is the equation, right? 2r sine alpha over 3 alpha. So in here, you realize that alpha is actually not the full angle in your sector. Alpha is half the angle of your sector, and the radius of the sector is okay, that's r, and then the alpha must also be in what? Another important thing is your alpha must be measured in radians, and remember your center of mass of the uniform sector will be along its line of symmetry. So you can see I have drawn the line of symmetry and I marked the point G here. So OG distance, the center of mass distance, is found by 2r sine alpha over 3 alpha. Okay. So we are going to use that, you can use that equation here, and we are going to get this, we are going to try to do this proof. Let's see. The uniform lamina ABCDE shown shaded in figure 3 is formed by joining a rectangle to a sector of a circle. Okay. The rectangle ABC has AB equals to EC and AE equals to BC. Okay. The sector CDE has center C and radius A. Okay. They say angle ECD is 5 over 3 radians. The center of mass of the lamina lies on EC. Okay, now they say the combine. Now you have your rectangle here and you have your sector here. So both of these rectangle and sector has their own center of mass separately. But when you combine them together, the center of mass comes into a new position. Okay, so depending on the mass ratios of both of these objects. So they say when you combine the two objects together, the center of mass of the lamina lies on where? The combined center of mass lies somewhere on top of the line EC. So this is G. So they are asking you, show that by using this fact, they are asking you to show that A equals to root 3D. Okay, how do we show that A equals to root 3D? Okay, so basically what we do here is, let's do in the normal way that we do for center of mass, where we actually what? Where we mark coordinates and we take the masses by the areas. We take the areas, we say the area is proportional to the mass. So let's make a small table and get it done. So object, mass and center of mass. Okay, so for the first object, I'll take my, okay, I have taken this object here. So for the first object, I'll take my rectangle. So how do we take the mass of the rectangle? So mass is proportional to its area, isn't it? So mass is proportional to the area. So we can say, if you take only the rectangle, the mass, the area of the rectangle is length into breadth, which is what? A into D. Are you with me? A into D. So mass is proportional to the area, and center of mass of the rectangle, you know, the center of mass of the rectangle lies exactly in the middle of it, right? So where do we have the center of mass here? So if you're using the center of mass, you need to use one coordinate as, you have to select a certain point as your 0, 0. Where do you prefer to use as 0, 0? Do you prefer, if you want, you could use B as 0, 0, or you could use this point C as 0, 0. Which one do you prefer? Okay, so then I'll take the 0, 0 at the point B. So you could take it at the point C. Definitely you have the freedom to do that. That's no problem. So my center of mass, if I take B as 0, 0, the center of mass X coordinate. So actually, I will be working with the X coordinates. Why is that? So they have told us here that the center of mass of the combined object is somewhere on EC, right? So if the center of mass of the combined object is somewhere on EC, it means I know which coordinate. I know what coordinate of the center of mass do I know? I mean, you can see we don't know the y height, but from this 0, 0 point, I definitely know the x distance to this point G, the combined center of mass, which means what? Which means we know the value of what? We know the value of our x bar. X bar is equal to D. Do you agree with me? Because they say the center of mass of the combined object is on the line EC. And since I'm measuring my coordinates from this point B, the distance, the horizontal distance from B to this point G is D directly. Okay, so I'll work with the x bar coordinates, x coordinates, and try to prove that what? A is equal to root 3D, because we need to prove A equals root 3D. Okay, so we will use the coordinate that we know and we'll try to find. Okay, so then what do we do here? The x coordinate is what? The center of mass of the rectangle, the center of mass coordinate is, the x coordinate is how much? Horizontal distance is exactly D over 2, right? We take half the distance. You could even fill in the y coordinate here to make things easier for you later onwards. The y coordinate also, if you fill it, the y coordinate would be how much? A over 2. So this will be, the x coordinate is B over 2, y coordinate is A over 2. Anyway, we will be using the x coordinate to do this sum. Then the next one I will be working is with the sector. Now the sector is a little bit tricky. Why is the sector a little bit tricky? Because in the sector, the center of mass of the sector lies on what? The center of mass of the sector lies on its line of symmetry, isn't it? The center of mass of the sector is lying on its line of symmetry. Along its line of symmetry, it lies at a distance 2r sine alpha over 3 alpha. It's along its line of symmetry. Okay, so getting the center of mass is going to be a little bit tricky here. Okay, before that, I think we need to get the mass. Shall we fill in the mass? How do we get the mass of the sector? The mass is proportional to the area. So what is the area of the sector? Area of a sector is half r square theta in radians. So half r square is a square, theta is pi over 3. Do you agree with me? So when I simplify, I get 1 over 6 a square pi. Okay, 1 over 6 a square pi. And then let's write in the center of mass. So this is the tricky one. So can we first find the distance O2? Let me say that this point is x, the center of mass. So OX, CX is the center of mass. So you know, along its axis of symmetry, the center of mass lies at a distance 2r sine alpha over 3 alpha. Shall we find that value? By the way, what is the alpha here? Are we using pi over 3 as alpha? No, you must take half of this angle as your alpha. So you can see here 2 alpha is pi over 3. Okay, so alpha will be half of pi over 3, which is pi over 6. So then let's get the distance of the center of mass along the line of symmetry, the CX distance, which gives me how much? 2 R is radius is a 2a sine alpha. Sine alpha is sine pi over 6 divided by 3 alpha is pi over 6. So what do we get here? 2a into sine pi over 6 is sine 30 is half, right? 3 times pi over 6. So 2 and 2 cancels out. And here 3 times 1, 3 times 2 cancels out. So what do I get here? A divided by pi over 2, which in other words becomes what? 2a over pi. Do you agree with me? So this distance, the distance along the line of symmetry, this particular distance is 2a over pi. Okay, 2a over pi. Okay, so then how do we get the x and y coordinates? Resolve. So when you resolve, you can get the x and y coordinates. So half of the angle here is pi over 6. So resolve by using pi over 6. So you can get your x and y coordinates. So what's the x distance here? This x distance here is 2a over pi, the distance, with what? Cos or sine. If you want to get this height, it's going to be not cos. If you take this, the vertical height is going to be cos now. Okay, 2a over pi, cos pi over 6 is the vertical distance. So I want the horizontal distance. So then it's going to be 2a over pi, sine pi over 6 when you resolve this distance. This distance is 2a over pi times sine pi over 6. So you agree with me? Okay, so then, and then this particular distance is the y distance, and that is found by what? This distance is 2a over pi cos pi over 6. Do you agree with me? This is 2a over pi cos pi over 6. Okay, so now if I'm writing the x and y coordinates, I told you I'm measuring it from B. So what's the total x distance from point B to this point x? The center of mass of the sector. What's the total distance from B to point x? What's the distance from B to x? The x distance will be D plus the 2a over pi sine pi over 6. So I think if you use the C as 0, 0, you would have gotten the answers quite easily anyway. So let's do in the way that I've taken. So D plus 2a over pi sine pi over 6. This is the x coordinate from the origin to the point, to the x distance from the origin to the center of mass of the sector. And the y distance also, let's mark. Y distance will directly be 2a over pi cos pi over 6, right? This is the xy coordinate. And then finally, let's try the center of mass of the compound figure. The compound figure is when you have the rectangle and the sector, both of them together. So rectangle and sector, both of them together, the total area will be what? The total area will be the addition. AD plus 1 over 6 a square pi. Okay, so this is the total addition of the area and the coordinates. So then finally, the composite object center of mass is the x bar, y bar. So I told you already from point B, we know the x bar value. What's the x bar value? The x bar value we told you, I told you all here. The x bar value is D because they have told the center of mass of the composite figure lies on EC, which means the x bar figure is D and the y bar figure we don't know. Okay, so now what we'll do is let's take moments. So all we need to do is once we have our mass ratios and the center of mass ratios all fixed, we can simply use moments and we can try to get the show that. So since I know the x coordinates, the x bar coordinate here, what I'll do is I'll use moments for the x coordinates and try to get the show that where we need to show a is equal to root 3d. Let's try it. Let's take moments. So what do we get here? AD times D over 2. So this is all adding, right? Plus, okay, multiply the mass at the center of mass. I'm doing the x coordinates. The next one is half a square pi over 3 multiplied by D plus 2a over pi sine pi over 6. equals to what? Total mass into the x bar, which is D. You see, mass into center of mass into center of mass equal total mass into the x bar distance. This is clear. So then we'll try to simplify here and see if there's something common to each and every term that we could remove. I think we can see we can remove a letter A here, right? Each and every term, there are 1, 2, 3 terms here. So each and every term has a letter A. So I'll remove has a letter A. Yes. If I remove, let me take it out. Let me simplify a little bit further so that I'm sure that you can see it clearly. So I get here A D into D is AD square over 2. Half A square pi over 3 gives me 1 over 6 A square pi. D plus 2A over pi. How much is sine pi over 6? How much is sine pi over 6? Sine pi over 6 is half, right? So here AD plus 1 over 6 A square pi. I can take A out. So D plus 1 over 6 A pi. Okay, so now I can easily cut off the A value. So it's clear because I've taken the A out from here. It's easy for me to cut off a single A value from every single term. So A square, when I cut out a single A, another 1 A is remaining. Here the A is gone. Okay. So now what we need to do, we need to show that A equal root 3D. So we need to kind of like make, take the remaining A's into one side and make A the subject. So D square over 2, shall we open the bracket here, 1 over 6 pi. So opening the bracket with 1 over 6 pi, I get here 1 over 6 pi times D. And here when I open the bracket, yeah, so this is 1 over 6 A pi. Yeah, the A square is cut, there's A remaining here. So 1 over 6 A pi and D. So 1 over 6 pi A and D. Okay, the letters you could do in any order. Then here again plus 1 over 6 A pi. We need to multiply with what's inside the bracket. So I'm multiplying now this with the second term. It's 2A over pi times half. Okay. So this is equal to D plus 1 over 6 A pi. So simplifying, what do we get here? D square over 2 plus 1 over 6 pi A D. Here we can simplify, 2 and 2 will cancel out. Okay, 2 and 2 cancels out. Okay, so I hope this part is clear with y'all. I take the 1 over 6 pi and multiply with D here, that's this term. Then again, I take the 1 over 6 pi and multiply with the second term. So that's over here. That's what's happening here, okay? So when I cut off, I can even cut off pi to pi here as well, right? So what's remaining? I get here 1 over 6 A square, isn't it? 1 over 6 A square is all that's remaining here. On the other side also, let's open the bracket with D. D into D is D square. 1 over 6 A pi into D is 1 over 6 A pi D or pi AD. Okay, so now I need to make A the subject, right? So you can see we have, do we have any like terms? Yes, 1 over 6 pi AD and again plus 1 over 6 pi AD. Basically, if you took this plus 1 over 6 pi AD to the other side, it would go as a negative, isn't it? So it would go as a negative and you would see that that 1 over 6 pi AD will entirely what? Cancel out. Because this will go to the other side as a negative and positive 1 over 6 pi AD cancels out with negative 1 over 6 pi AD. So what's remaining at the end of the day, I'll keep the 1 over 6 A square here and having D square, I'll take the positive D square over 2 here to the other side as negative D square over 2. What do we get? 1 over 6 A square. So 2D square minus 1D square is D square over 2. 1 minus half is half. So I end up getting here, we are trying to make A the subject, right? A square equals the 6 goes to the other side, 6 times D square over 2. 3D square, which gives me A equals to root 3D square. So we can bring the D out of the root. So I get root 3 times D. Okay, so this is to show that. Okay, so moving on to part B. The lamina is freely suspended from B and hangs in equilibrium with BC at an angle beta to the angle beta radians to the downward vertical. Find the value of beta. Okay. So how do we find this beta? Okay, so we have the center of mass position at G at this point G here. So they say here that they are hanging, they are suspending this object from B. So what's the theory when you suspend an object from a certain point? The theory is that when you suspend an object from a given point, basically that point and your center of mass will become what? This point and your center of mass will become the downward vertical. So basically the line that I drew here, the line connecting B and G is going to be your downward vertical. They are saying here the angle between what? The angle with the lamina is freely suspended from B and hangs in equilibrium with BC at an angle beta radians to the downward vertical. So this is beta radian. BC makes an angle beta radians to the downward vertical. They are asking you to find the value of beta. Well, how do I find the value of beta? So you can see here we already have a right angle triangle here and we do know the x distance. The only thing that we do not know here is the y distance. So basically it's the y bar distance that I need because the y bar distance gives me the center of mass position. The y distance of the center of mass position from B to the point G. So this is the vertical distance. So I need to find y bar. How do we find y bar? So I have already done some workings. The mass ratios and the center of mass coordinates are already written here with respect to B. I have written the center of mass coordinates with respect to B. So because of that, all I need to do now is to find the y coordinate. So I have written the mass ratios and the center of mass y coordinate. Just multiply. So we'll multiply. I have here AD into A over 2 plus 1 over 6 A square pi times. So multiply 1 over 6 A square pi multiply by 2A over pi cos pi over 6. Okay, and then this is equal to total mass, which is AD plus 1 over 6 A square pi into the y distance is y bar. So this is what you're trying to find. Okay, so we need to find this. Okay, so then we need to, we can use the help of what we have done in the earlier part. They've given us A as root 3D. So let's try to find y bar in terms of D. Okay, so removing the A. First of all, let's take the common thing out and remove the common things. So I get here AD into A over 2 gives me A square D over 2. Here, let me simplify. I can cancel out the pi to pi. I can I cut off 2 times 1, 2 times 3. So I get here A square into A is A cube over 3. Cos pi over 6 is how much? Cos pi over 6 is root 3 over 2. Equals in here, I can take a out. And I get D plus 1 over 6 A pi into y bar. So now when I've taken a out, I can now remove A from all the terms, remove 1A. So from A square, when I remove 1A, a single A remains. From A cube, when I remove 1A, A square remains. And here the A will completely move out. Okay, so let's simplify. I get here AD over 2 plus A square. Or let me write here root 3. 3 times 2 is 6, root 3 over 6 A square. Shall I get the common denominator here? So D over 1 common denominator will give me 6D plus A pi over 6 times y bar. Okay, so it's a simplification that's a little bit tricky here. Okay, so then let's try to input the A value as root 3D. Let's input the A value as root 3D and this should simplify. So replacing all the A values with root 3D. So root 3D into D over 2, or basically root 3D into D gives me root 3D square over 2. Do you agree? Root 3 over 6 into A square. So what is A square? A is root 3D. What would A square be? If A is root 3D, A square would be squaring both sides. Root 3 becomes 3, D becomes D square. Do you agree? So A square is 3D square equals 6D plus A is root 3D, right? root 3d pi over 6 into y bar. Okay, so then let's simplify. So I think we can take a d out from here and we can add these two as well. So root 3 d square over 2 plus 3 root 3 d square over 6. So we can add it add the value here and write a single d square value. So let me type here. I get root 3 over 2 plus 3 root 3. 3 root 3 3 root 3 over 6, right? Root 3 over 2 plus 3 root 3 over 6. So we'll time this, I get root 3 directly. You see? So root 3 what? Don't forget the letter. Both of these are d square terms. So I end up getting here what? Root 3 d square. In here I can take a d out. Let me take a d term out. I get 6 plus root 3 pi over 6 into y bar. So a single d will again cancel out and I can now make y bar the subject. So I get y bar equals 6 root 3d divided by 6 plus root 3 pi. So this is the answer for y bar. And then we are supposed to find the value of beta. So beta is what? To find tan beta, you can see to find the beta value, I will use beta. Tan beta is opposite of adjacent, which means y bar divided by the x bar. Isn't it? Y bar divided by x bar. The d value was our x bar, isn't it? The x bar was d. So let's find the answer. Tan beta equals y bar divided by x bar. So y bar is 6 root 3d divided by 6 plus root 3 pi. Y bar divided by x bar. X bar is simply d, right? Or if you want, I can just write like this, divide by d. So y bar divide by x bar. Okay, so division to multiplication. The d becomes 1 over d and you can see the d and d will cancel out. So now it's tan beta. Basically tan beta equals 6 root 3 over 6 plus root 3 pi. Okay, so type in the cal tan inverse in radian mode. Make sure your cal is in radian mode. Tan inverse 6 root 3 over 6 plus root 3 pi. And then we get the angle here. So this is the angle beta in radians, 0.7373. So there to 3SF, 0.737. Beta equals 0.737 to 3 significant figures. So I hope all of you are clear with the working that I did here. Okay, question number 8. The fixed point A is h meters vertically above the point O that is on horizontal ground. Okay, the point A is h meters above the point O on the horizontal ground. At time t equals 0, a particle P is projected from A with speed 10 meters per second. The particle moves freely under gravity. At time t equal 2.5 seconds, P strikes the ground. Okay, so that time 2.5 seconds is the place where it strikes the ground. At the point B, at the instant when P strikes the ground, the speed of P is 80 meters per second as shown in figure. So they've given you the speed. By considering energy, find the value of H. Okay, so they're asking you to consider energy, meaning, you know, in a projectile, energy is completely conserved. We have conservation of energy here. So basically what we need to do is use conservation of energy at the point A and at the point B. Energy at A is equal to whatever the energy you have at B. So I will consider the potential energy 0 level as the ground. So what energy do we have at the beginning? What energy do I have at the beginning? At point A, what energy do we have? We have, you can see we have the speed 10 and we have the, and we are above the ground, h meters above the ground, which means you have kinetic energy and potential energy. Do we need to do components of the velocity of the speed here? No, if you take components, you'll be working with velocity vector. So don't go for components because we need to, energy is a scalar quantity. So we are not bothered with about the direction. Okay, so whether this is pointed up, this is pointed down, does not make any effect for scalar quantities. Okay, direction is not needed for scalar quantities. So for energy is a scalar quantity. So here, the initial energy we have kinetic energy plus gravitational potential energy is equal to what? So initially I have kinetic energy, potential energy. At the very end, what do we have? At point B, what do we have? It strikes the ground with speed 18, with speed 18, which means we have kinetic energy. Do we have potential energy? No, because it's it's at the ground. There's no height. So kinetic energy half m into 10 square plus GP is mg h. H is the height, the vertical height above the ground. Equal kinetic energy half m into 18 square. So now let's simplify. How do we simplify? I think all of these have the letter m in common, right? So remove letter m. So half into 10 square, what do we have? Half into 10 square, 10 square is 100, 100 divided by 2 is 50 plus GH equal half into 18 square. How much is it? $162. So I get here GH equals 162 minus 50. So H equals 162 minus 50 divided by G. So you should know by now in M2 we use G as 9.8. So type this in the cal 162 minus 50 divided by 9.8. And I get here H is 80 over 7 or 11.4. So first I'll write the exact figure, 80 over 7. Which is equal to 11.4. 11.4 meters, correct to 3 significant figures. Okay, next part. Find the distance OB. Okay, so find the distance OB. What should you do here? Okay, in part B, they ask you to find the distance OB. So how do we find the distance OB? So, what I've explained to you, we need to find what? We found the H value in the previous part, right? So we need to use, what's the equation? We need to definitely go for the motion equations in part B. So I will go with the motion equation what? Since we know the H value, and to find the distance OB. OB distance is actually the horizontal distance. But before I find the horizontal distance, I need to find what? I need to find this angle, the projection angle here. So you can take it as theta or alpha. I'll just take it as alpha. So you need to find the angle at which this is projected. Okay, so because to find the horizontal distance, I'll have to use S equal UT. To apply S equals UT, I need to know the alpha value. So what I'll do here is, first we will use S equal UT plus half AD square vertically. And when you're applying it vertically, I mean, you have to choose, you can choose to apply S equal UT plus half AD square either upwards, or you could choose to apply it downwards. It's entirely up to you. So I will choose to apply it downwards. Okay, so when you apply it downward, starting from A to point B, now remember you are starting from A. So when you start from point A, the displacement from point A to point B is what? The displacement from point A to point B is, you can see it's H, right? The shortest distance from A to B is H, but it needs to be, I mean, is it positive or negative? Is it positive or negative? But since you can see from point A, our displacement is downward, isn't it? So we have positive H here. Okay, there's a small thing here. This should be 10 cos alpha, right? Yeah, this should be 10 cos alpha and 10 sin alpha. Yeah. So I'm applying it downwards. So because I'm applying it downwards, starting at the point A, I have my displacement positive H. In an event, if you use the equation upwards, S equal to, you must input here as negative H. Okay, because if you because we are measuring the displacement from point A. So from point A, I have defined my positive direction downwards. So from point A, if I'm moving downwards, I get positive figures. Or from point A, if I move up, I'll get negative. So now the U value. So what about the vertical component of velocity? So what's the vertical component of velocity? Vertical component of velocity is 10 sin alpha. But 10 sin alpha is acting which way? Upward. Since I use downward as positive, it's going to be minus 10 sine alpha. Minus 10 sine alpha into time. So what's the time taken for the whole journey? They've told us the time taken is 2.5. So plus half AD square. So the gravitational potential, gravitational acceleration is 9.8. Acting downwards, I'm also using the equation downwards. Therefore, it's half into 9.8 into it's positive 9.8 into time is 2.5. 2.5 square. So let's simplify and what? Make sine alpha the subject. So my H value I found as 80/7 minus 10 times 2.5 times sine alpha plus half into 9.8 into 2.5 square. So let's make sine alpha the subject. Okay. So I'll take this sine alpha term to this side and I'll take the 80/7 to the other side. I get here 10 times 2.5 sine alpha equals 80/7 goes as minus 80/7 plus half into 9.8 into 2.5 square. So that get the answer, I think we'll definitely go with the decimal answer here, right? And you'll have to get sine inverse and get the alpha value. So work on this. So we'll type here. Minus 80/7 plus half into 9.8 into 2.5 square, and I get 1075/56. So making sine alpha the subject. 1075/56. The 10 and 2.5 will come down, right? So basically 1075/56. This answer will be divided by 10 times 2.5. So I get here 43/56 sine alpha. And let's get the alpha value. Sine inverse 43/56 gives me. So we'll go with degree mode, right? Have they given us any mode here? Yeah, we'll go with degree mode. It's easier for us to work here. So degree mode, sine inverse 43 divided by 56. So what do we get here? 50.1618, 50.16185. 50.162 degrees. Is that okay? So now what we need to do is we'll need to find the value of the horizontal distance. So how do we find the horizontal distance? The OB distance, we will apply S equal UT horizontally. Apply S equal UT horizontally, then you won't get an acceleration. So U is 10 cos alpha because we are applying it horizontally. The horizontal component of velocity is 10 cos alpha. Time is 2.5. Okay, so here we get S equals. Now here they have not specified to you whether the answer should be exact or whether the answer should be decimals. But if they do say that they want the answer as an exact, then you could find the cos alpha value by using the sine alpha ratio. You have the sine alpha ratio here as 43/56. So you could use the, in an event they ask you the exact value or maybe some kind of a show that with roots, you could use the identity sine square plus cos square equals 1 and input the sine alpha value as 43/56 and actually get the exact cos alpha figure in third form. Okay, so here they have not asked us to give the exact answer, so we could leave our answer 3 significant figures. So let's input the value and get it done. 10 times I'm going to use cos alpha as 50.162 times 2.5. So input the value, get the answer. 10 times cos 50.162 times 2.5. What do we get here? 16.0154. So basically to 3SF we get OB distance is 16.01, right? So which means 16.0. So correct to three significant figures. The answer is 16.0. Okay, so moving on to part C. They say here as P moves from A to B, the speed of P is less than or equal to 8 meters per second for capital T second. Find the value of capital T. Okay. So they say the speed. Again, the word is speed. The speed is less than or equal to 8 meters per second. Now you realize that point A, you start with the speed of start with the speed of 10. So obviously you realize when you're going up, the speed is what? Gradually decreasing. The speed gradually decreases, and there's a point here on your path where the speed becomes 8. Okay. So then basically they are asking you find the time limit, right? Where the speed is less than or equal to 8. So what do you need to realize here? First thing you need to realize is that this projectile is symmetric. Therefore, whatever the speed you have here, when you draw a horizontal line and go to the other side of the projectile, you have that exact same speed on the other side. 8 meters per second, but it's to the other side. So basically, the region where your speed is less than or equal to 8 would be what? You realize that the more you travel up from this point, you're going to lose in speed, right? So at the highest point, the speed doesn't become 0. At the highest point, the y component of the velocity becomes 0, but the x component will be 10 cos alpha. As you should know that in projectiles, the horizontal component throughout the entire motion will be constant, isn't it? The horizontal component throughout the entire motion will be this 10 cos alpha. That will not change. So anyway, so what's my time duration here where the velocity, where the time, speed is less than 8? So it's this duration. So now what I'm trying to do is I want to find this time gap that I've marked here in yellow. How do I find this time gap? So what I'll do here is I will use the fact that horizontal component is constant throughout the entire motion. So I'll use here the x component. What do we know about the x component? Let's talk about part C. What do we know about the x component? The velocity x component is always 10 cos alpha, isn't it? 10 cos alpha throughout the entire motion. But also, let me say that this angle here is theta. I'm going to use this angle here as theta. It's the same angle theta that would come to the other side. So this angle theta, I could resolve and take a horizontal component from the 8 meter per second as well, right? I could say the horizontal component here is also what? 8 cos theta. Are you with me? Because here if you resolve the 8 meter per second and take the horizontal component with the angle here, it's a different angle I marked as theta. I get 8 cos theta. So 8 cos theta should definitely be equal to 10 cos alpha because throughout the entire motion, horizontal component remains the same. So from here, I can find the value of cos theta. Do you agree with me? Cos theta equals 10 cos alpha over 8. Do you agree with me? So I get the value of cos theta here. And then we can get the cos theta value here. Let's input it. 10 times cos alpha was how much? Cos 50 point. How much was the alpha? 50.162. So I think it's better if you could use more significant figure. Okay, is equal to cos theta. So what do we get here for theta? Cos inverse. So I get the ratio 0.800. So then take cos inverse of this answer, right? And I get 36.7959. Is that okay? I get 36.7959. Now, I have the theta value here. So all I need to do is to find the time duration to go from this point. Let's say this point is A. We have already used it. Let's say this point is X. And let's say this point is Y. I need to find the time taken to move from X to Y. How do I find the time taken to move from X to Y? We could use what? We could use, for example, the vertical component at X would be 8 sine theta, isn't it? Here the vertical component is also 8 sine theta. So you could use V equal U plus AT from X to Y because you know the starting speed and the ending speed. Starting speed is 8, here ending speed is also 8, but the directions are different. And you can find the time duration. Or else what you could do is, some of you might think, okay, this is symmetric. Why not we use V equal U plus AT from X to the highest point, At the highest point, you know, the vertical component is 0. So you could use V equal U plus AT from X to the highest point and actually get this time gap and multiply that time gap by 2. We could do that also. Okay, so we could use a V equal U plus AT from X to the highest point. Okay. And we could get this, and we could get the, we can get the time. So shall we work on this? Okay, so we'll use V equal U plus AT from X to Y directly. Okay, so I'm gonna use to find the time duration where the speed was less than 8 seconds. I will be using V equal U plus AT and I'll use it directly from X to Y. Okay, I'll directly use it from X to Y instead of using from X to the highest point, and I could find the time and multiply by 2. Or else we can directly use from X to Y. Just make sure you use the directions properly with the angle. So we will be, choose your positive direction. What's the positive direction you want to choose? You can use upwards as positive or downwards. So anything. So I will use downwards as positive. It's entirely up to you. So then in that case, V is the final speed at Y. At Y, the final speed is 8 sine theta equals U. U is the initial speed, which is 8 sine theta, but it's upwards. Therefore, minus 8 sine theta. Okay, and then plus AT, acceleration is 9.8 downwards. So therefore, plus 9.8 and into TT is what we need to find. Take the 8 sine theta to the other side. So 8 sine theta plus the 8 sine theta is 16 sine theta equals 9.8 T. Input the value here, sine 36.7959. Let's input the value, get the answer, give the final answer to 3 significant figures. Divide by 9.8. Give the final answer correct to 3 significant figures. 16 sine 36.7959 divide by 9.8. And I get 0.9779. So this is an estimated answer, approximate answer. So 0.978 if I leave it to 3 significant figures. Okay, so the answer is 0.978 to 3 significant figures. Make sure you keep your answer 3 significant figures because we have used G as 9.8. So whenever we you should know, whenever we use G as 9.8 in a sum, since G value 9.8 is an approximation, we should leave our answers to 3 significant figures. Okay, so that's the reason why we leave even the H value 80/7. We should leave the final answer as 11.4 to 3SF because we use the numerical value of G as 9.8, which is an estimated value. Okay, so leave the in these kinds of sums. In that case, leave your answer, final answers to 3 significant figures. So this is the end of the October 2021 M2 paper.